Consider the following problem. Which of the following alcohols has a higher boiling point? Is it the propanol on the left, or is it the ethane diol on the right? So, right from the beginning, we have to recognize the property which makes the boiling point of certain alcohols very high, and that is called hydrogen bonding. So hydrogen bonding occurs when hydrogen bonds with fluorine, oxygen, or nitrogen. So the acronym is that hydrogen likes to have fun, which is FON in this case. Now the reason why such a bond, which we do have right here, the reason why such a bond increases the boiling point so much is because the electronegativity value of hydrogen is 2.1, and the electronegativity of oxygen is 3.5, meaning that the electrons in the bond between oxygen and hydrogen are going to be pulled more toward oxygen. So this value, this number, represents the strength by which the atom is going to be pulling on these electrons. So these electrons are a little bit closer to oxygen than hydrogen. The electrons are not being equally shared. Because of the unequal sharing of electrons, the oxygen is going to have a partial negative charge, and then the hydrogen is going to have a partial positive charge. Now, when this happens, when hydrogen has a partial positive charge, it tends to be a very extreme partial positive charge, because hydrogen usually, when it's bonded covalently, only has 2 electrons, and these are the only 2 electrons it had. So once it has those electrons taken away, it doesn't have any other electrons around it. Like, they don't exist. So that nucleus, that positive nucleus, has a big impact to pull negative things toward itself. And so that's why it's very strong. Now, what is the mechanism by which it is going to make the boiling point go up? So if I redraw the same structure as we have here, obviously when you have propanol, you're not just going to have one molecule of it. You're going to have lots of propanol molecules in a container. So if I redraw the structure here and give everything the correct charges, the hydrogen will have a partial positive, partial negative for the oxygen. What's going to happen is that the oxygen is going to, that's partially negatively charged, is going to be attracted toward the partially positive charged hydrogen, because opposites attract when it comes to charges. And so you're going to get this force that is going to be very strong, because hydrogen doesn't have any electrons around it. It's just one proton that is pretty much naked and can pull things like a partially negative oxygen toward itself with a lot of strength. Now this makes the boiling point go up, and so on the molecule on the left, if I just erase everything that we've drawn, the molecule on the left has one case of hydrogen bonding. In other words, there's one opportunity for hydrogen bond. With this one, you actually have 2. You have 2 of it. So because there's 2, you need twice as much energy to release those bonds in between the different oxygen and hydrogen atoms. So this one is going to have a higher boiling point, so this is the answer. And if you want exact numbers, this one, 1,2-ethane diol, has a boiling point of 198 Celsius, and then this one, 1-propanol, has a boiling point of 97. So you can see that it's almost twice as much as the propanol, and that corresponds to having twice as many situations for hydrogen bonding. So I hope that explained this concept and why something like a diol, which is an alcohol with 2 hydroxyl groups, can have a higher boiling point than an alcohol with 1 hydroxyl group, given that the molecular mass of the 2 alcohols are generally close to one another.